So eliminate the parameter and the parametric equations. You've probably seen videos or done topics on this, different situations. This one is similar to a situation we had before where we want to get the variable t by itself. So I just added 3 to both sides over here. It's just going to be a bit of a longer substitution. We want to have everything in Cartesian form. That means we want x and y to be directly related to each other. We don't want this variable t playing along anywhere. So in order to make that happen, we're going to plug y plus 3 everywhere where we see a t in here. So this is y plus 3 squared plus 4 times y plus 3. So just remember, there's no distributive power of an exponent. It's not y squared plus 9 here. We have to multiply this as 2 parentheses that are the same because it's being squared. So we do that, y times y makes y squared, y times 3 makes 3y, plus another 3y, plus 9. So x, let's see, this part here, when we square it, it's y squared plus 6y plus 9. And then over here, if we distribute that 4, it's 4y plus 12. And then just to clean things up, get combine like terms. That's 10y plus 21. X equals y squared plus 10y plus 21. That looks like the one that matches what we have here. Similar to the last question, we want to get t by itself. One thing to probably avoid here is don't try to get t by itself over here for y, because right now t can take on only positive values. If you get t by itself, then it's going to imply that t can take on negative and positive values. Actually, if you add 3, square both sides. No, it'll be only positive values because t is going to be squared. So I think it's actually okay if you want to tackle either one of these two. Just get t by itself. So over here, I'm going to take the x function. Divide both sides by 4, so t is going to be x plus 2 divided by 4. And then that lets us rewrite y. Y is going to be the square root of x plus 2 over 4 subtracted by 3. That doesn't match any of our answers here, though, so let's see if we can do expand. So because that square root, that's not going to expand nicely. You know, you could try to square both sides, but you don't distribute that squaring power, so that's not going to come out really nice and clean. So let's actually take a different approach. Let's go back to what I was speculating on here in the beginning. Let's get t by itself up here. This is y plus 3 equals the square root of t. And then if we square both sides, yeah, this still works because since y plus 3 is being squared, t can only be positive values, which is what we said in the beginning for this function. So if we take y plus 3 squared and plug it into x of t, now it's starting to match our answer choices. These both will be the same. This one would just take a lot of algebra rewriting to get something over here. The second one that I just worked on is probably going to come out a lot quicker. So remember, y plus 3 squared, you got to write that off to the side. That's y plus 3 times y plus 3. And if you do that, it's going to be y squared plus 6y plus 9. And then if we distribute that 4 and subtract the 2, nine, 18, that's 36 subtracted by 2 makes 34. And we could factor out a 2, but it doesn't look like they have that in the answers. So x equals 4y squared plus 24y plus 34. This matches what we just got over here.